How's it going, guys? Welcome to the first video lesson I'm putting out there. While we're learning how the course works and how all this stuff kind of fits together, I thought I'd start with something pretty basic that you hopefully remember from previous math courses, but it's still super important for this course. And I'm going to show you how to graph any function. So if you're like, what's that word function mean? Okay, that's bad. But hopefully you know what a function is. If not, I will remind you. Come on. Didn't work, of course. I will remind you how function or what a function is. So a function is a mathematical relationship between two variables or quantities. You have your input variable and your output variable. I plug something in, I get something out. So for example, there's a function that could model my hours worked, and when I plug in the amount of hours I worked, I would get out how much I get paid. In calculus, we're dealing a lot with how things change. So the rate at which something enters into a tank will tell me how the total amount that comes out of the tank. That's kind of an end goal of this course. Or the time I'm going at some, at time 5, how fast am I going, things like that. So I'm today just going to show you how to graph some basic functions. I'll be talking a lot about some keywords that you've hopefully heard in the past, and then I will show you how to find the x-intercept and the y-intercept. So first example is going to be super basic. I'm going to remind you of one of these functions right here. Our first function, y equals 2x minus 1. Probably saw this way long ago in your first kind of middle school, high school math courses. This is called a linear function. What makes it linear? Well, the shape, when you start to graph it, makes it pretty obvious. But the structure of it, there's no squareds, cubes, there's no absolute values, there's no exponentials. You have just your quantity x being multiplied by this coefficient and then this constant at the back. So when you first saw these, you may have learned how to graph them with mx plus b form, but in this class, I want to focus more on the function nature of these, meaning if I can plug in something for x and I get an output, then that gives me a coordinate, and that coordinate is part of this function. So I like to use something that looks like this. That was a little wonky, but that's okay. And I call this my in-out table. And mine might look a little bit different than yours or you're used to seeing, because I like this little middle section if I'm doing things by hand to do my work, to keep things organized. So I am going to pick a value, plug it into the function, and get an output. I like to start with 0 for reasons that will come into play more as we go. So you take 0, you plug that into the function for x, you substitute it in, and if you get an output, that's the relationship between the two variables that this function creates. So right here, I'm going to plug in 0. 2 times 0 is 0. 0 minus 1 is -1. And we have our first ordered pair or coordinate that is representative of this function. You plug in an input, you get 1 output. Now, if you plug in an input and get 2 outputs, that's not a function, because a function is what we call one-to-one, meaning one input has to have only 1 output. You can't have multiple outputs, otherwise it's not a function. And you guys have hopefully seen some of those in the past. So continuing on, I'm going to plug in 1, and 2 times 1 is 2, minus 1 is 1. I have my second coordinate. And one more. I'm going to plug in 2, and you can keep going and going and going. 2 times 2 is 4, minus 1 is 3. So my third coordinate was 2, 3. How many do I need to plug in? Well, depends on if you know what the function's supposed to look like, and you need to plug in as many as you need in order to get the shape correct when you try to graph it by hand. So I think this is enough. I know what a linear looks like. If you don't, I'll remind you in a minute. But this is enough for me to get the graph that I want, the sketch of the graph. By the way, if you notice, the y inputs are increasing by a constant rate. From -1 to 1, I jumped up 2. And 1 to 3, I jumped up 2. That'll come into play a lot later, but that's called the slope of this function. This has a constant slope, just a little teaser for later. I'm going to graph these coordinates in Desmos. Desmos is great when you're working at home on some of these and you start to get confused by some of these functions. Don't be scared to use Desmos. It's free, it's online. Hopefully you've seen that before. I would plug in the points to start and try to figure out if you can see the shape that you should be getting. So here are the 3 coordinates. There's one, there's the other, there's the other. And yes, it's linear. Linear means it's going to be a line for the shape. So spoiler alert, we should be getting a line. And yeah, if I played connect the dots, I would probably get a line. So at this point, might as well see how we did. I want you to be able to do this by hand, but checking your answers is definitely fine with me. And yeah, that's the shape we should be getting, a nice line. So we have graphed our first function together. I'm going to show you now how to find the x and y intercepts of this function. So let's find the x-intercept. Find the x-intercept. You're going to hear me refer to the x-intercept as something else in this course a lot, either the root or sometimes we'll call them the zeros. So if I say find the x-intercept, I'm asking you to find the root, 0. It's all the same language. I like root a lot. Root just means where the function equals 0. So that's basically how you're going to do it. It's where your function equals 0. That's what we're looking for. This is function notation right here. That means a function of, and then this is the variable you're plugging in for. So I'll show you that on the next problem. I used y in the previous. You can think of this as y for now. But when I want to find the x-intercept, you take the function 2x minus 1 and you set it equal to 0. And you have a little equation that you need to solve. So you need to use whatever algebraic strategies you have to solve this equation. I'm going to add the 1 over and divide by 2. And lo and behold, I get x equals 1/2. Now, some of you like to give this to me as a coordinate, which is fine. I actually don't mind this answer in this class, as we'll see going forward, but you can give me both. But the x coordinate a lot of times is going to be what we're looking for. The y coordinate varies on its importance. And check this out. I am a big fan of, does your answer match up with what you are telling me algebraically and graphically? And yeah, you can see that the x-intercept, or where I cross the x-axis, is right at the 1/2 spot. I didn't get any other answers. I didn't get any weird answers. So it looks like my work checks out. The other thing I'm going to want you to be able to do is find the y-intercept. This is the one typically we like more because it's always kind of the same process. You need to plug in 0 to the function because I want to know when I plug in 0 as my x coordinate, what is the corresponding y coordinate? So you substitute in or plug in 0 for y. Okay, well, we actually already did that, but I'll do it again here anyway. So here's my linear function. I'm going to plug in 0, and we get the coordinate -1. Now, the y's I typically do want as a coordinate, so you can give me 0, -1. So if I ever ask you for a y value, give me the entire coordinate. It'll help down the road. And does your answer check out with what I expected? Yeah. My y-intercept looks to be at 0, -1, and the algebra checks out. So this is a pretty basic problem, but there's a lot going on here with being able to find the x-intercept, or intercepts if there's multiple, and finding the y-intercept. All right, let's do one more together, and I'll kind of walk you through some things I need you to remember for today. Let's clear the canvas. Let's try a more interesting function. So how about, on this time I'm going to use function notation, so f of x equals, let's do something that's not linear, like this. This is where we'll have to kind of work together and remind ourselves things we learned in the past. If you've had me, you've seen these functions a lot. This is not linear. What is it? Well, the squared kind of gives it its form. So when you see x squareds floating around in your functions, that's going to tell you what type of function it is and also the shape of it. So when you have squared as your biggest power, that means you are dealing with a good old quadratic. And man, we study quadratics lots in other courses. So this is a quadratic, and if you know the shape of a quadratic, great. We'll get to that in a second. I don't need you to know that right now. I just want you to graph it. So when you see a function and you're like, man, I got to graph this thing, go to the tried and true method of in-out table for now. That is how we can always get an idea of what is going on. So x, and this time instead of using y, I'll use f of x, the function evaluated at that specific x coordinate. So if 0, 1, and 2 worked on the last one, no reason they shouldn't work this time. So I like to put in parentheses what I'm substituting in when I start getting to exponents floating around. 0 squared, 0, minus 4 is negative 4. 1 squared minus 4 is negative 3. 2 squared minus 4 is 0. Looks like we have 3 coordinates to work with. Great. Let's see if I can get a good idea of what the graph looks like from 3 coordinates. So I'll go back to Desmos. Come on. There we go. Go back to Desmos. Get these out of here. I'm going to plug in the 3 coordinates we just found. So 0, negative 4. 1, negative 3. And 2, 0. We get a line. Well, kind of. If I connect 2 dots, I can get a line. So my advice, never use 2 points. Use more. And then it bends. So what is this? 2 bendy lines and that's it? Well, no. Something else is going on here. So this is where I always say graph as many points as you need until you see the shape you're supposed to get. And that's why in previous math courses, we stress knowing the functions you're kind of looking for. So I'm hoping you remember that quadratic should be parabolas, like a U. And I don't see a U here. So what's going on? Well, I'm guessing the rest of the U is over here in the negative section. So that means you got to go back to the in-out table, do a little bit more work, and maybe plug in a negative value and see what that gets you as an output. So I plug in negative 1. I square it. I get 1. 1 minus 4, negative 3. So we have another coordinate. Now, on the previous one, I said you're never allowed to repeat inputs, like meaning one input should not get 2 outputs. Is it okay if different inputs get the same output? Yeah, that's definitely fine in a function. You can have one, as long as this input only has 1 output. If a different input has the exact same output, that's fine. It's still what we call one-to-one. So in that case, we can plot that point too. And by the way, if we plugged in negative 2, we would get the coordinate 0. So adding these 2 coordinates into the graph will hopefully allow us to see that parabola shape that we're supposed to get. It's negative 1, negative 3, and the last one that we did was negative 2, 0. And now I'm starting to see a parabola. So a lot of times when you guys graph parabolas, you make this a little point. For now, I'm not going to be picky, but as we go through this class, parabolas don't end in points. Parabolas end in a nice, smooth kind of transition. So look, it levels out here for an instant and then goes back up. That's going to be a major point of this class. So little things like that, we're going to have to start stressing. For now, I just want you to get the points on there and graph a rough sketch. That'll be fine. Parabolas are important. Quadratics tend to, increase at an increasing rate. It's a lot of calculus jargon right there, but all good stuff that's going to be coming down the road. All right, so to finish this off, let's find the x and y intercepts of this function, this quadratic. All right, and I'm back. Let's find the x and y intercepts. So the x-intercept, same thing. We set the function equal to 0, meaning we set x squared minus 4 equal to 0. And this looks like a problem from integrated 2 or integrated 3 when you're starting to solve quadratics. How do you solve this quadratic? Quadratic formula? Great, you can do that. This one's a little bit simpler. Probably don't need to do that. Complete the square? Wow, you do not need to complete the square. If you're learning to do that, go for it. You can solve it kind of like you would any equation where you isolate x and use techniques of getting x by itself. That's what I'm going to do in a second. Or you could factor it. Factoring is a great strategy. We're going to use that a lot. I actually probably would factor this if it was me, but I want to show you something with getting x by itself. So I'm going to go through and I'm going to add the 4 to the other side. And then, man, I got to get rid of that squared. So what is the inverse that undoes a squared? Well, when you take a square root. Squared and square root are inverse operations. They kind of undo each other. So undo each other. If I square something and then square root it, I get back to my original number. That's what inverse means. So I'm left with just x on this side. Great. Square root of 4 means what times what is 4? That's definitely 2. And a lot of you would stop there and be like, I'm done. There's my x-intercept. But there's something crucial you got to remember. When you take a square root to solve something, there's a little bit more going on. If you go back to this previous step and think about what works when you plug it in. When you square 2, you get 4. I definitely agree with that. But when you square negative 2, remember a negative times a negative is a positive, you also get 4. Negative 2 is a solution of this equation. It's a solution of this equation, meaning it's one of our solutions, which is why we use a plus or minus. Plus or minus means 2 and negative 2 are both solutions or roots or zeros of this equation. It's a root of the function. So we have 2 roots. Can you have 2 roots? Yes, I said you can have multiple roots depending on what the type of function is. And does that match up with what we should expect to see? Definitely. I see 1 root, I see the other root, 2 roots. So we're going to have to go back and remember some of our algebraic strategies for solving equations, which is why if you had me for integrated 3, we worked a lot on solving different types of equations, because calculus is a lot of algebra. It's a lot of graphing, it's a lot of algebra, it's a lot of function analysis. So you have to have some good algebra skills in order to get the information you're looking for. The y-intercept, pretty basic. You plug in 0, you get negative 4. I'm not going to go through the math on that one, but you could, or you're going to when you do your problems. So tonight you're going to graph some functions. If you get stuck, use Desmos. This is just to get you familiar with submitting assignments and Canvas and all that. And then tomorrow on the warm-up, I'll throw some more interesting functions at you, and we'll together try to remind ourselves how to solve some of these more unique functions. I guess it won't be tomorrow. It'll be a couple days block schedule. But we're going to be looking at all types of functions this year. We're going to be looking at linears, quadratics, cubics, quartic, quintics. Those are called polynomial functions. We're going to be looking at exponential functions, logarithmic functions, absolute value functions, rational functions, trigonometric functions. And we are going to be doing lots of calculus type things with those functions. We'll also see some piecewise functions again. I'll teach lesson on that soon enough, because I'm sure a lot of you don't remember those, and we'll go back and look at rational functions too. But for tonight, just make sure you can use an in-out table and find the x and y intercepts. All right, guys, if you have questions, call me in Zoom. Let me help you as you go through some of these on your own. And thanks, guys.